All right, here's part two of our video, phylogenetic trees. We had part one, and the link for part one's down below if you need to look at it. So again, when we're talking about phylogenetic trees, we're talking about evolution. We're talking about evolutionary descent, where we can see two organisms where they share a common ancestor. So let's get a clean page and explain that. All right, so let's say we have this organism over here, A, and an organism B. And at one point in time, as we go back, there was a common ancestor. It's that point right there. There's the common ancestor. And we call that, again, it's the most recent, we'll say that, the most recent common ancestor as of now, right? Because, phylogenetic trees can change when we get more information, like science. That's what science does. It changes when new information come about. So let's just say this is the most recent common ancestor. And it's also the node. It's a node. So A and B share a common ancestor at this point. Now, the phylogenetic trees don't always show when that happened. So, and of course, this ancestor, we're not just talking about a single individual, we're talking about a population. Population that's split off. It's split off into A and B, certain point in the past. And we can keep going, right? Because we can say that we can make another node. Let's say there's another node over here and branched out, until to an organism called C and an organism called D. And you can keep going. So the time goes this way from the past, we'll say the past to the present. Time is going left to right. So you can see that C and D shared an ancestor with A and B over here at this node. So just looking at this, you can see that A and B are more closely related than C and D. It's just obvious. But A, for example, A, even though it's more closely related to B, if we look at C and D, it's equally related to C and D. It's not, can't just say that A is more related to C than D, because they both share this second common ancestor in the past. Let's use some animals now. I'll clear this out. So let's say we had a lion. I'll put the lion over here. Use the big cats. And then we have over here a leopard. So the lion and leopard are more closely related than any other cat of the big cats. And of course, there's that ancestor in the past. We'll call that node 1. Doesn't have to be node 1. We just made it node 1. Right? And then if we create another part of this tree, we can see another ancestor over here. And that branched out, let's say, into the jaguar. So the lion and leopard are more closely related than the jaguar. If we look at the jaguar, it's equally related to the lion and leopard because they both share a common ancestor at node 2. And we can break this up again and make another node, another common ancestor. Call it node 3. And at node 3, we can get, let's say, the snow leopard and the tiger. Can't leave out the tiger. So just looking at it, we know the snow leopard and tiger are more closely related than any other cats. But if we look at the jaguar to the snow leopard and tiger, the jaguar is equally related to the snow leopard and tiger. Right? You can't say the jaguar is more related to the snow leopard than the tiger because they both share a common ancestor right over here. Now, what these phylogenetic trees do not show is they don't show how this happened. That's one thing we should know. Let's put some of the things that it does not show. It does not show, put a little box around that, how this happened. Right? And we don't know We do not know, although we could find out perhaps in the future. We do not know who or what the common ancestor was until we get more information. So we don't know what was node 3 or node 2 or node 1. We don't know those. Another thing we should look at is we can't assume just because the lion and leopard branched out that this ancestor just died off. It could have continued for a while too. So that's important to know. All right, let's look at another example. Okay, we used dogs. We used cats. Let's use dogs now. So let's have our dog. We'll put the dog here. And the gray wolf. Depends how you spell wolf. Some spell it with an A-Y or E-Y. So the dog and the gray wolf had a common ancestor over here. You can see that. Again, this is called the branch point or the node. That's the most recent common ancestor. And we'll just create a tree over here. Here's another common ancestor. And that would split out into the coyote. So right here you can see that the dog and the wolf, the gray wolf, are more closely related than the coyote because they have a more recent common ancestor over there. The coyote shared an ancestor with the dog and the wolf 2 nodes ago, right? There's 1 node, 2 nodes. And if we continue over here, we can have the red wolf. So the red wolf is equally related to the dog and gray wolf as the coyote is. And then we can create another one. We'll create another node here, node 3. And we'll get the fox. So just looking at it, we know that the dog and gray wolf, again, are more closely related than the fox is. But if you say, how is the fox related to the dog and the gray wolf? They're equally related. You can't say the fox is more related to the wolf than the dog. They're equally related because they shared a common ancestor here. And if we look at the coyote and the red wolf, right? The fox shared a common ancestor with the coyote and the red wolf right here at node 2. Now this could be misleading because we can also, if we change the pen, we can also have, if we look at this right here, we could have just made the coyote over here and the red wolf because they share that common ancestor right over here. So from the fox to the coyote and red wolf, it's just one. The last time they shared a common ancestor was right over here. And of course, again, time is going from left to right. And some phylogenetic trees do not show when that happened. But whatever this time was, in the past, right over here, there would have been a lineage where all of them descended from. All right, that's our video today.